Hello there and welcome to Mastery Tutoring. I'm a tutor, Kara, and today we're going to be doing this amazing question from the 2018 Paper 2 IEB Final Exam, question 4. Please, if you are new to this channel, subscribe to our channel and share the link to this video with your friends. Be the first one to share this video to your school-related social media groups. That would be your WhatsApp and Facebook groups. Without further ado, let us solve this question. So the statement reads as follows. Use the diagram below to prove the theorem that states the angle subtended by a chord at the center of a circle is twice the size of the angle that it subtends at the circle. All right. So we are given a circle here, and then we have about 3 points that are on the circle, which is A, B, C, and then also we have our origin or center there, which is O. So now we are required to prove that angle AOC is equals to 2 times angle ABC. Let's go right ahead and prove that. So now before we start the proof, we need to construct a line on the diagram. The line is going to start from B and then it will pass through O to a point on the diagram, on the circle. So let me put my point there. It passes through O and then it goes straight to the circle. I'm going to name it point D. Now, since we have this, now we can start with the diagram, right? So in fact, before we start with the diagram, I almost forgot. Let us name this one 1 and 2. So this one is going to be 1 and then this one is going to be 2. So we have O1 and 2. So the angle O1 is divided into 2 parts, right? Now we start with our proof, right? So in fact, just to help you understand how I did this question, I've divided the proof into 3 parts. So there's part 1, but remember when you're solving this question, you don't have to divide it into any parts. There's part 1 and part 2 and part 3. So now for part 1, right, we are looking for angle O1. Angle AOD. O1 is equals to ABO plus A. Some error this one. It's ABO plus BAO. So now we need a reason, obviously. So the reason for this is that exterior angle of a triangle is equal to sum of interior opposite angles. So look, I'm trying to say is that O1, remember this is O, as much as it's not visible anymore. This is O1, right? So this angle O1 is equal to this plus that. Now look, OA it's a radius, and then also OB is a radius. Now since OA and OB are equal already, we can say that this angle BAO and angle ABO are equal because it's an isosceles triangle. So that is going to be our next step. So ABO is equals to BAO. Now the reason to this one, we're going to say equal radii because we have isosceles triangle. This is triangle ABO. Okay. So now that we're saying that angle ABO is equal to angle BAO, we can simply say that A1 is equal to ABO plus ABO. Now instead of writing both of them, we can choose with one. And then obviously we're going to choose ABO because we are trying to prove that this angle, let me just indicate with a red color, We're trying to prove that this whole angle is equals to, is 2 times, in fact, we're trying to prove that this angle is equals to 2 times that angle. So therefore, we're choosing ABO. Okay, so now this part, it adds up to 0.1, and simply say is 2 times AB. Yeah, so this is part 1 of our solution. So this is the end of part 1. Now we're going to move to part 2, and I'm going to repeat myself. You don't have to divide this this proof into 2 parts or 3 parts. I'm doing it because I want to help you understand, because I don't want to be rushing through like a lot of steps, So if I divide them into 2, it becomes much easier for you to understand the picture that I'm trying to depict here. So this is part 2, right? And then part 2 is going to focus on triangle CBO. So now, part 2, we're going to be looking for A2. A2 is equals to, now this is our A2 here, is equals to CBO plus BCO. And then it's similar to what we did, it's exactly the same thing, but then it's just that we're dealing with a different triangle, so the angles are going to be different. The naming of the angles are going to be different, but then the reasoning behind will be exactly the same. So exterior angle of a triangle is equals to sum of interior opposite angles. That is our reason there. And then also, because OB and OC are radiuses, they equal, they make triangle CBO an isosceles triangle. Based on that, we can safely say that CBO is equals to BCO. And the reason to this, as I've already explained, is that it's equal radii. Now, it's an triangle CBO. Okay, so with this information now, we can say O2 is equals to CBO plus CBO, which becomes 2CBO. So this is part 2, the end of part 2. Now we're going to go to part 3 now. So this is part 3. Part 3, it's going to look like this. So now we are looking for angle AOC. Angle AOC is given by what? By O plus O2. So now let's substitute the values of O1 and O2. So O1 is 2AB ABO plus 2CBO, which becomes ABO. So it's 2 in brackets. We can factor out the 2 in brackets. We have CBO, which eventually becomes 2. ABO plus CBO, guys, is the same as AB. ABC, and then now this simply proves our question, but not entirely, right? No, it proves our question. Therefore, it has been proven that AOC is equal to ABC. So there's our proof. I hope you learned something from this. So thank you for joining me, and leave a comment if you have any question or recommendation. And don't forget to subscribe, to our channel. Goodbye.